Hello YouTube, my name is Travis. Today we're going to be taking a look at something interesting you probably didn't know about the Oort cloud beyond our solar system. So if you don't know, the outside perimeter, the furthest part of our solar system, you enter this cold region called the Oort cloud. And basically the Oort cloud has anywhere between 1 to 1.4 trillion, maybe even more, comets at the very edge. Now keep in mind, the further out you go, obviously the longer the circumference, the longer its orbit. But if you ever wondered, like Halley's comet, for example, how many other comets are beyond that point that we probably haven't even seen yet? These big giant celestial balls of energy that are just hurling through space, colliding with one another, getting knocked out of their orbit, and then going in whatever direction they get flung into. But it is very interesting to sit down and think about, though, nonetheless. So, anyways, I think it's very interesting because it really just goes to show you how many objects we don't even understand and how many other forms of unknown bacteria and rocks that we probably haven't even have on record, let alone, classify them as the elements and all that, which would be even more interesting. So, it really does make you wonder, how many things we don't know. It wouldn't surprise me that there's life out there on other planets too, because, it just, like I said, the further you go out, the more, mysterious it really does become. 1.3 to 1.4 trillion would probably be more accurate considering the fact that they still don't even know what the mass is. So usually when that's the thing, you can really assume that it's like all the way around and how big that is. So if that's true in the sense of its perimeter, the amount of rocks that are flying around in that region of space has got to be cold, frigid, and not even like warm to begin with. But it's so big and so mathematically probable that there's got to be a huge number, like something like a trillion, maybe even more, based on a computer that's counting all of it. But it is interesting to see, though, nonetheless, though. If we could get more pictures of it, that'd be even better, though. We could really learn a lot about, the rocks, the space, and, just even the region, maybe even the matter that's even found in that area, whatever gems they can find there, whatever elements we can pull. Maybe we could find some newer elements we haven't even nailed down yet. Some comets obviously could probably be even bigger than the Earth, maybe a little bit smaller, but it really does go to show you that just how big some of the size and some of these rock structures can be, and they obviously could hail from anywhere in the universe because there's no doubt in my mind that some of them could have gone into like the nearest galaxies too, because or the nearest solar systems, because when something goes flying out of its orbit, it doesn't necessarily mean it's tide locked to whatever position that it's in. It could very well go flying out of something else, especially if it ping pongs enough. As something travels through space, obviously it burns up too, but celestial rocks eventually find their way back into another portion of the universe, and whether they travel very far or they just stay where they're at, they're definitely very old rocks. We're talking like millions, billions of years old. They could have very well have been in multiple locations to the point where that's how evolution could have started. And it's also interesting because like that's what a lot of people don't understand about even our evolution, for example. Like there's tons of bacteria that's in our bodies and other living organisms that we still have no understanding of because we don't know everything about it, and that is proof right there that they had to have come from like other regions of space all throughout wherever. It just creates different chemical and physical changes within the physical appearance of genetic structure. It's very interesting nonetheless, cause and effect. So it just inhabits, and then it travels through time and space. It's even more nuts to think that some of these comets that have been discovered are actually bigger than some small cities that we see in like obviously like the United States, for example. And there have been reasons to believe that there are actually even bigger ones out there. And I keep in mind that every single time like an asteroid like is traveling through space, it can also obviously, like, the more it crashes into things, it breaks into smaller pieces. But eventually over time, if done correctly, the gravitational of orbit, like something orbits around it, like our moon, for example, did the same thing. it can remerge into a bigger rock with no surface or no or its core and its surface, but no atmosphere, for example. So it's interesting to think like how, you know, you look at all these giant rocks flying around in space, and maybe their origins are obviously the hardest part, trying to figure out where they're at or where they came from or what they are. But really, truthfully speaking, we can at least imagine that they can very well be repaired given it enough time. And some of these rocks are so old, you know, there's no reason in my mind they wouldn't be older than some stars themselves if you can sort of wrap your head around that lifespan. But this is just to show you that this is just, you know, the universe really is a big possibility. Everything in space moves, and the more energy that's being created, the more possibilities there are too, with that analogy. So that's how fast it's accelerating. So yeah, hopefully you learned something. But anyways, you know, again, subscribe if you're not already. If I find any more information, I'll let you know. But you know, if you have any requests, let me know too.